Physics 5, round 4, stage 1. And let's take some time to introduce ourselves to you guys. I'm Candy from the Desert University.
Good morning, everyone. My name is Chen Hongyi from the National Taiwan Normal University.
Good morning. I'm Yang Songwei from National Taiwan University.
Good morning, everyone. I'm Jimmy from National Java University of Education.
Thank you.
And let's start from the recording.
Okay, hello everyone. We're Team Maxwell from Belgium Senior High School, and I'm telling you that this is my injury, well,
And your comments?
Everyone, we're Liu Zhi, and整体考试是张宇，这是这一是程序，所以刚才是。
Hello everyone, we're Team Jungda from National Java University High School. And I'm the leader of the team. My name is Chen Yan. And these are my teammates. She is Chen Xi, she is Chen Ren, and she is Chen Liqing, she is Thank you.
We should start. The opponent should pick your problem for the recording.
We want to try to talk planning meeting.
Sorry, which number?
54.
reject.
Reject.
The number 4 is rejected.
We want to try to understand and work.
Number 7 is available.
Yeah.
It's not on the video.
Yes, because if the challenge available is less than 5, it's not okay. So
Okay. Problem number 7. Do the planning. Okay, now record it at 5 minutes. along the back.
Okay, hello everyone, I'm a reporter from Team Maxwell, and today I'm going to report problem 7 ruler kit. So for the problem statement, it said two rulers are tightly held against each other, and we put a round projectile inserted the two rulers close to one of their ends, and we apply extra force on the surface of the rulers. The projectile will be ejected at a high speed. So we have to investigate the effect and the parameters that affect the ejection speed. So according to the problem statement, we have two types of extra force. The first type is slow pushing, and the parameters for this we have applied point, projectile diameter, flexural rigidity, and friction. And the second type is sudden force, and we have the parameter for it is the height of weight. So first, the observation one for slow pushing. When external F is applied to the rulers, projectile will be affected by pressure and friction. And once the force exceeds the threshold, projectile will be ejected out. So the setup for observation one, we have two identical rulers. Both a fixer help us to hold the rulers tight each other, and a force applier connected to cycles that help us control the extra force. Next, the observation 2 is the sudden force. So when a sudden force is applied to the rulers, it will suddenly cause the ruler bending and also the big deflection at the same time. So because of big deformation, it will have the projectile will be ejected out at high speed. So the setup for observation 2 added a pulley to help us easier to control the sudden force. So from the previous observation, we can notice that the mechanism that is related to friction and elastic force. So first, we're going to introduce investigate the friction part. And in this part, we're going to explain how stick happen in the ruler kit. So first, when we apply the force on the surface of the rulers, the projectile will be held by the rulers because of static friction. So it will first stick, but when the external force exceeds a threshold that overcome the maximum static friction, that it will start moving and be pushed by the rulers. And because in this process, the static friction will change into the kinetic friction. So if the initial speed is not big enough, it may be held again by the rulers because of the kinetic friction. And until the projectile moves to the end of the rulers, or the initial speed is big enough, it will stay again and be ejected out by the ruler. So next, we want to find what is the ejection condition. So when we are keep applying the force, the angle of bending will increase it. And when the angle is increasing, the horizontal force push the projectile towards will become bigger and bigger, and the force that hold the projectile back caused by the friction will become smaller and smaller. So we found out that once the theta is equal to arctangent, the coefficient of static friction, the projectile will be ejected out because they both overcome the static friction. Then we want to find out the elastic force caused by the rulers that apply on the projectile. So for this we use overhanging beam to model the system. And from older Bernoulli beam theory, we can find out that the force applied on the projectile by ruler bending will like this formula. next, we're going to investigate how different parameters will affect the initial speed as the problem state. So the few parameters like will investigate about the applied point, which will adjust the distance between the applied point and the contact of the rulers. And then also we've mentioned that the elasticity and friction is important in this system. So we'll investigate it. And also the both sides will cause different angles that it will cause a different it will related to ejection condition. So first we'll investigate the applied point. So in this case, because as you can see, the formula for f prime is like this, and it actually will keep increasing. But the fact is that we want the velocity that is not completely related, just related to the force in, also related to the angle that we want. We want just the horizontal force, and also when we are adjusting the distance a, the angle of bending will be different. So this kind of factors will make the result like this. It is like something wavy. So, and then we're going to talk about the experiment that how projectile's diameter will change the velocity, initial velocity. So here we use a whole projectile, and that you can see the force formula applied on the projectile is like that, and so the diameter of the ball is increasing. It will lead to the velocity decreasing because when the particle size is bigger, as you can see as before, the bending of theta is bigger, and that we just have to bend a little so that it can reach the ejection condition. So because we just bend a little, that it won't cause much force applied, much elastic force applied on the projectile. So it will cause the bigger size cause the lower velocity, initial velocity. But if the projectile is too small, that the angle of bending is too small, that it can't reach the ejection condition. That like when we do 3 centimeters, it can't fully eject out, even though we have push the 2 rulers against each other. So we have to investigate how the smaller projectile diameter will affect the initial velocity, we have to adjust the applied point. That if the applied point is much closer to the projectile, that we have more distance that we can bend. Also we can have bigger angle that it can reach the ejection condition. So the result is similar to the previous one. When the diameter of the ball is bigger, it will lead to the velocity is smaller. And then as we talked about, the elasticity is very important in this mechanism. So to focus on, to concentrate on the just elasticity, we have to keep the friction coefficient the same. But so we put tape on the surface of the rulers, that the same tape that, and so the coefficient just decided by the tape and the projectile. So the friction is the same as we change the rulers. So what this means that when you change the materials of the rulers, it will change the flexural rigidity, which is the EI. And as you can see in the formula, EI increase that as our result the EI, which is electrical rigidity, increase that it leads to the velocity rise up. And also, we have to measure the electrical rigidity, so we apply the force in the center of the beam, the beam is like a simple support beam on the two both sides of the rulers. So by this formula, we can count out the electrical rigidity. And also, we've noticed that the friction force is really important in mechanics. So when the maximum of static friction force is bigger, it means that it won't move such early that the potential energy is stored and kinetic energy of the ball will increase because the potential energy is much higher. So as a result, when the static friction coefficient is increased, that the final velocity will increase. So we also change the Stirling force that the potential energy of the weight will change into the kinetic energy and then change into the potential energy of the rulers, and then also change and then finally change into the kinetic energy of the projectile. As you can see, we have v squared in velocity squared in the kinetic energy. So this will be h is proportional to v squared. And as you can see, we count the kinetic energy and the potential energy, and there's something energy lost in this. So finally, we find out the elastic and friction is important, and the main mechanism is the ruler bend, and finally the friction causes
The reporter signed up. The opponent will put into the questions. Keep your question short.
How can you calculate to control force?
So the weight is fixed at so like this. The weight is fixed at a fixed height, and we will release it at this height.
Have you considered extending and vectorization? Have you considered rotating vectorization?
Yeah, it also will.
And can you turn your patient? Can you explain how do you get this formula?
So this is all by reference.
And did you figure data in the formula, or you didn't measure it?
Yes, these are our own
effect and parameters between them. Yes. And this is the summary of the report. He puts in his theory, he put ejection and goal is to be his parameters. And this one is the elastic force overhang he using in his. And this is his experiment. He set up in slow pushing. He made two parameters. One is slow pushing, and the second one is sudden force. And his parameters. The first in the experiment is projectile diameter, and the second one is applied force, and the second one is friction, and fourth is height of weight, and five is ball size. He changed different ball size to be the different parameters, and the last one is elasticity. And this is the discussion we just talked about. The first one is the reproducing detecting the effect of friction. And the second one is how to make the same force from the setup. And I want to ask, Ale has said yes.
You mean the different size of ball is the same answer? Yeah, so and will also affect, but if it's the whole ball, so it doesn't affect that much.
How do you determine the coefficient in your experiment? Because you just say coefficient in your experiment.
What?
We can discuss this. And I want to ask you, heavier mass usually make a higher velocity, and how do you think?
Can you say?
Because the heavier mass will cause the higher mass. So, because we store it the same high level, and how do you think you put higher mass and you will make the higher velocity? Or you didn't?
In the certain force part.
Yes.
So our potential energy is like it's mgh, and as we change in my first experiment, I changed the height, and you mean I changed the m, which is the mass of the weight, and it is also they also can affect the potential energy that finally change into the kinetic energy of the ball and cause the velocity to be high.
And do you think the air resistance will cause the ball eject out slowly or not?
Not because we just focus on the initial speed, and that is a really short process.
Okay, and I want to ask, how do you reduce the errors in your experiment?
Reduce the errors.
Yes.
So that we did a lot like 10 frames of experiment.
And can you turn this to page 15? Can you explain the formula?
So
And why do you use this formula?
here will be fixed that do not cause momentum. So we use this model. It is a big model. Yeah, so this is a theory about when we apply the force in the middle of the beam, that the beam is difficult support, and we can apply the force and we measure the delta that we can calculate out the flexural rigidity, which is EI and EN, and we use it to explain the result that was shown in the previous chapter. The more flexural rigidity will affect the higher initial velocity.
How do you measure and how do you get data output?
So we use chapter 2. We use like 480 and CSI camera to collect the data, and we use chapter 2. So without the initial speed.
And what is the EI? ENI?
So the E is the Young's modulus, which is related to the material, the average material, and I is the second moment of area, which is related to the B, which is the width of the rulers, and the H is the thickness of the rulers.
Okay, and I want to ask what's the if you want to calculate it, you still have to calculate it.
Yeah, so if all the length that like B and H is meter, and so if they are all meter and the I is meter the 43, and the E we use in here we calculate out is the BA, and this number is really big, so in the previous page we use GPA to show this.
Okay, and can you explain how your experiments work?
So, which experience?
The whole experience.
Okay, so you mean the how the
Yes, how you do the flow and take the
okay, so in the setup page we will show that here's a plier that can make the same force from two sides of the pole, and we connect the handle to a system that we slowly pump the water into this, that we can make sure the applying force is slow enough.
Okay, and where do you move your camera?
So the camera will be like this, and it is in the ruler like this, and it is from this. So we can change the initial speed like in the horizontal axis.
So you do many twice and you do test
for slow pushing, we don't push much extra force than you need to inject it out. But in the certain force cases, because we use certain force, it will certainly give much more force than it needs to inject it out. So maybe the ruler will assert something absorb more energy than the slow pushing force.
Okay, and which feature is this invariant? Is because we add more force and there are huge many friction and you talk about safety friction or the another bias.
So you mean?
I mean, in this experiment, which friction causes the difference? Just the
So the main difference in the we did the friction affect the initial speed, and we did that by static friction, the maximum static friction, because we think that the more the maximum of the static friction is, the ruler can store more elastic energy, and it will cause the finally kinetic energy change into the ball different higher and cause the initial velocity.
okay, that's
Okay, you're going to summarize the discussion.
I'm asking the formula in his experiment that he didn't explain clearly in his report. And the second week, I asked him about the friction, and he said it's the static friction, and this is our discussion. And I asked him will the air resistance affect because the ball will eject it out, and he said no. He said they just look at the velocity that they just eject it out, so don't. And that's our discussion.
Okay, now the reverse control.
First question goes to the opponent and the reporter. What is the main force causing the ball ejected?
So the main force is the elastic force from
I think it's the first we put on the ruler and we will make this potential energy into the ball and the ball will eject.
Okay. Next question. You mentioned the ball will rotate around. What causes the rotation of the ball?
So because our system is like this, and there's the gravity that will cause the normal force different from the upside and downside.
Okay, about the opponent.
So you say,
What causes the rotation of the ball? Okay, next question. If the rotation direction will be different. The rotation direction,
Rotation direction.
like it will clockwise or counterclockwise. Do you investigate this?
I don't know.
What do you think? If the ball will rotation in clockwise or counterclockwise? Clockwise is like this, and counterclockwise is like this. Rotation like that. Yes, sorry.
I think it's the
between the rulers and the ball is also when it hit the ruler will absorb some energy, and after it might.
And about the continuous force.
Yeah, so it's from the rulers absorbing, so the slow pushing force might be it's smaller than the steady force.
Okay, thank you. Problem number 7, lunar cannon. And then is the problem statement. They ask the reporter to investigate the relevant parameter that affect the ejected speed. And our main focus first, the process during the ejection of the ping pong ball. And the second point is how the relevant parameter affect ping pong ball ejection speed. And that is a review of the report. And in the theoretical model, we mentioned the speed phenomenon and the ejection condition, and the hang beam and the force analysis. Their process is clear explanation of the ejection process of the ball, but the lack of clarified energy transformation, and also the energy loss, and didn't mention how he measured the applied force. And in the experiment setup, they use the slow portion and the sudden portion of the external force, and the applied point, and the projectile diameter, and the height of the weight, and the ejected speed and the friction. And their process is the way we releasing the weight, but it is inaccurate object, and the causes didn't manage control variable well. Like plastic is 20 centimeters instead of 15 centimeters. And in the data analysis, they analyze the eject velocity. Their process is well method of the mentioned elastic. But they inaccurate external data, like error rise too big, and lack of data point to investigate the phenomenon, and review of the observation. And their process is they clarify some detail of the setup, and clarify some false analysis. But the lack of question about the error analysis. In the discussion, they clarify about the formula, but they didn't mention the data graph, and two folks are clarifying the setup, and the lack of their opinion, and lack of the error analysis. And in the discussion, the opponent asked why higher mass will cause the higher velocity, and the reporter said the higher potential energy change into the kinetic energy. And I think it don't clarify which mass is the object. And if it is the object that jumping, then the greater mass will cause the greater velocity. If the wrong projectile, the higher mass, it will make the velocity slower. And next question is about the main force. I think the friction, I think the main force to causing the ball ejected is the friction and the component force of the normal force, both causing the ball to eject. The opponent said force, applied force on the ruler, and the report said the elastic force on the ruler. And in this point, they didn't mention why will the energy loss happen and the ways to measure the coefficient of friction, and didn't mention why will the ball ejected. And that is my presentation. Thank you.
So for the concluding remark in my report, I considered electrical rigidity of the ruler, and we control the extra force, and we have qualitatively described the ejection process and the mechanisms, which is mainly about the friction and elastic energy. And we consider ejection condition that will cause the ball ejected out. And we use beam theory to calculate the elastic energy of the ruler and the elastic force applied to the projectile. And we explain the multiple experimental results related to our parameters. And in the discussion, we discussed about the experiment setup, if it is controlled, and also the detailed formula explanation and how we model the system, and about how we record the data. We use tracker to track the center of the ball, and also the definition of the EI, which is mainly related to the material and shape of the roots. And also we discussed how to calculate the EI and the unit of ENI, which shows in my formula. And we discussed the energy loss as small rotation. But I think because the permanent station said that we have to put it close to one of the ends, and the distance from the ball to the end is very small, so the rotation, I think it is very small. And also we talked about the slow pushing or sudden force will cause different energy loss. And the sudden force will cause much more energy loss because the extra force that it need to eject it out. And also we don't really care about we control the deflection of the ruler instead of applying force. Thank you.
Thank you for the report. Now, the question from the jury.
To my eye, the velocity versus EI looks like a function of square root, right? Nothing proportional to square root of EI. And could you explain why for all three cases?
Yeah. So we just showed there are some errors that we showed in the error bar, and the trend is mostly complete based our formula.
So those are the big they not big. So why do they fit your theory?
So like we showed in the graph, the trend is big. When the EI increase, the velocity will increase.
Okay, so the functional form looks like a pretty non-completed square root of that. It's okay if you know it.
Your comment, you want to answer the question? You know, please answer the question. Okay, speak up. Okay, go ahead. Sure, Sugar, you didn't want to answer the question? Okay. You want to elaborate a little more?
Yes, so from the velocity is, so the kinetic energy, we know that is 1/2 times the mass and the velocity squared, and the square root of the velocity will equal related to the energy loss, square root of that.
I think the E is the elastic modulus, and the I is the second moment of area of the beam's cross section. So I think the unit is square.
I look at the formula. I think the yellow is like the velocity.
One question?
I just want to simply confirm today understand which about this consider. Could you please write that with unit of E and I equation?
So you know when I
E is next modulus, right? So what is the unit of that unit? For example, spectrum is a fluid energy.
So the E and so the I is equal to
Then
like this, and the E is or
I just want to confirm.
More question? Oh,
So, the recorder, just want to clarify. So, this slow pushing, you mentioned there's a slide stick, and the stage 3, you have stick before inject out. You have any data to confirm that it's really stick or down on the stage 3?
just as we observed that we put the ball in close to the end, but when apply the force, it will first move to the middle, and then it will stop, and again, finally it just
You have any data to confirm that? Just by eyes.
yes.
okay. Now we come to the discussion. And let's take the 75676. Okay, now we conclude the stage 1. Let's take 10 minutes break and let's go back.